Hey class, Mrs. Matheson here. We're going to cover Unit 6, Notes 5, our last one. And it's going to be on angle of elevation and angle of depression. So apply angles of elevation and angles of depression to solve for missing angles and side lengths in real-world problems. So really what we're going to do now is we're going to apply what we learned in the last few notes. All right, so let's just first define angle of elevation. Angle of elevation of an object, as seen by an observer, is the angle between the horizontal and the line from the object to the observer's eye, or line of sight. Okay, so all of our notes today are going to involve drawing some pictures. So because I'm drawing mine and you are all seeing these on the internet, you can draw yours on your paper. All right, so here's our observer. And it says the observer is the angle between the horizontal and the line from the object, the observer's eye. So let's say we're just taking a peek up at the sun or a bird or something in there, air. So we're looking up. So between the horizontal and that line, we actually have created a right angle. And this right here, that's a little theta that represents angle, and that's our angle of elevation. All right, so there's a picture to describe angle of elevation. Now let's talk about angle of depression. If the object is below the level of the observer, then the angle between the horizontal and the observer's line of sight is called the angle of depression. So let's say now you are up in an airplane in the sky. So draw yourself a little airplane. Okay, and you are looking down at a tree or something on the ground, a house, anything like that. Okay, so now we're talking about our angle is between the horizontal and the observer's line of sight. All right, so again, we've created that right angle, and here's our theta, and this is our angle of depression. But sometimes we use our angle of depression in this way. If we go down and over, this is also theta, and because of that, that is because of alternate interior angles. So we can use our angle of depression in a picture that looks just like angle of elevation, thanks to our alternate interior angles. So if you're not done drawing that, go ahead and pause the video. Otherwise, we're going to move on to our first one. So in all of these, we're going to draw a sketch to represent the problem, include the given numbers and the variable to represent the unknown, show the trigonometric equation needed to solve, and then give the solution. So a tree casts a shadow 25 feet long. The angle of elevation from the tip of the shadow to the top of the tree is 64 degrees. Find the height of the tree. So we have a tree here. So draw yourself a tree. All right. And it's got a shadow that's 25 feet long. And the angle of elevation from the tip of the shadow to the top of the tree is 64 degrees. We want to find the height of the tree. So this is our h. So now we're just using our trig ratios. So, ka, toa. Okay, so looking at this picture, from my angle, I have my opposite and my adjacent, because of my 90-degree angle here. Opposite and adjacent, I'm looking at using my tangent. So now we're just going to plug it in. Tangent of my angle, 64, equals opposite, h, over adjacent, 25. So we want to get h by itself. We're going to do that by multiplying both sides by 25. So h is going to equal 25 times the tangent of 64. Again, make sure that your triangle or your calculator is in degrees, not in radians. So if you have trouble with that, make sure you see me so we can get that figured out for you. Typing that into your calculator, we find a height of 51.3 feet. Okay, so let's go ahead and look at the next problem. Oh, jumped ahead one too many. A jet takes off and rises at an angle of 19 degrees with the ground until it hits an elevation of 28,000 feet. How much ground distance is covered in miles? All right, so we take off from the ground and it's 19 degrees. So there's our angle. And hits an elevation. Elevation is how high it is, so up and down. So that's going to be this side here. We want to know how much ground distance is covered. So there's our x. So thinking of SOHCAHTOA, looking at that, what do we have? We have our opposite and we have our adjacent. So in this case, again, we're going to use tangent. So tangent of 19 equals our opposite over our adjacent. So like we talked in class when we did our 6.4 day 2, when the x is in the bottom, we're just going to switch that with our tangent of 19. And we're going to divide those. Okay, so we get 81,317.9 feet. But it asked how much ground distance is covered in miles. So I want you guys to convert that feet into miles. And that will be on your quiz that you guys are going to take in Schoology. Okay, so let's see another problem here. Here we are going to see from the top of a vertical cliff, 40 meters high, the angle of depression to an object that is level with the base of the cliff is 60 or 34 degrees. How far is the object from the base of the cliff? Okay, so our cliff is 40 meters high. It has an angle of depression, so that's this, of 34 degrees. So if we have that there, we also can say we have 34 degrees down there. And we want to know how far is the object from the base of the cliff. So this is our x. So thinking of our SOHCAHTOA, we are going to see we have the opposite and we need the adjacent. So tangent. Not always going to be using tangent. Just want to throw that out there just as a disclaimer, but most of the time we're going to be using tangent. So the tangent of 34 equals our opposite over our adjacent. Again, we talked about we can switch our tangent and our x when x is in the bottom. Tangent of 34. Go ahead and do that in your calculator in degrees. And we come out with 59.3 meters. Great. Okay, let's take a look at problem 4 and let's get this one set up. The pilot sights at the beginning of the runway and must approach it at 5-degree angle of depression. If the plane is 182 kilometers from the beginning of the runway, ground distance, what's the plane's altitude? That's the height up in the air. So let's just draw ourselves. We are having an angle of depression that's 5 degrees. The plane is 182 kilometers from the beginning of the runway. So that's our ground distance. What's the plane's altitude? So that's our x. We are going to go ahead and we are going to use tangent because we have our opposite and our adjacent. So the tangent of 5 equals our opposite over our adjacent. And we are going to multiply both sides by 182. So x equals 182 times the tangent of 5. Go ahead and calculate that. We're going to get our answer in kilometers. We get 15.9 kilometers. All right, we're going to stop there. 5 and 6 are really great problems that we're going to talk about in class, so you don't need to worry about those. We'll converse about those and solve those in class. Don't forget to take your Schoology quiz, and we'll see you guys